Mr. Chairman, dear friends, my name is Ionel Pisa, like a tower, you know. And I represent the University POLITEHNICA of Bucharest. And I present the paper Reduction of Carbon Dioxide from Combustion Gases by Methanization. You know, the irony public number one is CO2. And we try to kill it, but it's impossible. Let's try to reduce it. This is our work, to reduce this CO2 concentration. This method, it's a physicochemical process transforming carbon dioxide into methane using hydrogen. The chemical reaction between pure CO2 and hydrogen leads to formation of CH4 and other vapors. The reaction is exothermic one, the temperature rising for each percentage of CO2 converted by about 63 degrees. The application of methanation to flue gas involves the presence of carbon dioxide mixing with another gases component. The usual volume of CO2 concentration being between 9 and 60%. This paper presents the particularities of the flue gas decarbonization process for this case. We have two possibilities to increase by different method the concentration of CO2 from 60% to 90, maybe 100%, to have pure CO2. But the costs are very important. There are many possibilities to increase the concentration of CO2. With nickel catalyst of calcium oxygen, but you see the cost is estimated at between 100 and 300 US dollar per ton. Anyway, we start the experiment with this concentration. This means usually concentration of CO2 in flue gases between 9 and 60%. The difference you will see between this concentration of CO2 and the pure concentration of CO2 involve a process methanization is serious. If I have the CO2 about 100%, is necessary one stage of methanization. If the concentration is lower, it is necessary 2 or 3 stages of methanization. The reaction between CO2 and hydrogen, it's usually there are 2 possibilities. First one, to obtain methane and water. And the second possibility by carbon, oxygen, and after that to obtain water and methane. The temperature and the pressure are very important in this process. Usually, the temperature is between 150 degrees and 500, and the pressure between 0.1 and 50 bars. But the best results were achieved at a pressure under 1 bar range and the temperature between 150 and 250 degrees. Obviously, the methanation efficiency also depends on the nature of characteristic of catalyst use. The efficiency of this method to reduce, to transform CO2 in methane, it's about 90%. This is the diagram of the flue gas methanization circuit, but in this diagram, the flue gas, anhydrous flue gas, dry. And this is a diagram, complete diagram, you know. First of all, we have to eliminate the water vapors. The second stage is methanization, and number 3 stage, it's another cooling, R2. In this case, the efficiency of this method it's better than I use the diagram with wet flue gas. In that case, where the flue gas are wet, this R1 is missing, and R2 becomes air, simple air. In this diagram, energy installation, ventilator, anti-methanation cooler, methanizer, final cooler, you know, all of the data and all the temperature between these 3 stages. If the concentration of CO2 in flue gases are usually between 9, we apply the scheme of methanization of serial reactors like in figure 2. The energy balance indicates in this relationship the entire power is given by ventilator power, the pump power, auxiliary fluid, and you already know that for wet flue gas, R1 is missing and R2 becomes air. The degree of condensation, which depends on the temperature, it's between 50 and 85%. Conclusions. The experiment are at the beginning. And the financial issues, it's very difficult to evaluate it. But we think the final cost will be double for the moment. The paper presents the particulars of the decarbonization process by methanization of flue gas from energy installations. The researchers are the beginning, so a special emphasis has been placed on the influence of flue gas composition. This research will be carried out for flue gas from the combustion of methane gas or liquid sulfur-free fuels. In Romania, we have a big power plant, especially coal. And you know, the union is very for pollution, and you have to close. Now with this period, with this crisis, we have to refunction these plants, because we have about 2,000 megawatt in this power. And this solution, it's a good one to reduce the CO2 concentration. For any questions, this my email address, ionel.pisa@upp.ro. Thank you for your attention. Thank you very much.